It's fascinating to think back to July of 1969, when the world held its breath. As we took those first steps on the moon, what once felt like pure science fiction suddenly became reality. Welcome to Cosmos in a Pod Space and Astronomy series. Today we're taking a deep dive into the Apollo program, not just that one giant leap of Apollo 11, but the entire journey, uncovering the challenges, the innovations, and, the lasting impact this incredible feat had on humanity. Now, what might surprise some people is how deeply the Apollo program was actually intertwined with something, well, far from scientific, the Cold War.
You're absolutely right. The Apollo program wasn't just about, scientific exploration. It was very much a product of this intense rivalry between the United States and the Soviet Union.
So would it be fair to say that the race to the moon was kind of like a proxy battle in this larger Cold War?
Exactly. In 1961, President Kennedy challenged the nation to land a man on the moon and return him safely to Earth before the end of the decade. And this bold declaration, it was really fueled by the desire to, showcase American technological power and to kind of assert its dominance on the world stage.
Yeah, it's incredible to think about the pressure that must have put on NASA. I mean, what kind of technical hurdles did they have to overcome to make Kennedy's vision a reality?
It was a truly monumental task. Imagine building rockets powerful enough to break free from Earth's gravity, designing life support systems that could function in the, well, completely alien environment of space, and figuring out how to navigate to and from the moon with the limited technology they had at the time.
That's mind-boggling.
Mhm.
Could you maybe give us an example of a specific technological challenge and how they managed to solve it?
Well, take the life support system, for example. One crucial component was the carbon dioxide scrubber. You see, astronauts exhale carbon dioxide, which can be toxic in a confined spacecraft. So they developed a system using lithium hydroxide canisters to absorb that carbon dioxide from the air, ensuring a breathable atmosphere for the crew. And then they also had to figure out how to provide clean water in space, right? So they developed this closed loop water recycling system. It collected and purified wastewater, including urine, turning it back into drinkable water, which was essential for these long duration missions.
Wow, that's incredible. It sounds like they were constantly having to innovate and push the boundaries of what was possible. But I imagine they must have encountered some pretty serious setbacks along the way too, right?
You're absolutely right. And one of the most devastating was the Apollo 1 tragedy in 1967. During a pre-launch test, a cabin fire broke out, tragically killing astronauts Gus Grissom, Ed White, and Roger B. Chaffee.
What a terrible loss. That must have just shaken NASA to its core. How did they even respond to such a tragedy?
Well, the Apollo 1 fire forced NASA to really take a long, hard look at its safety protocols. It was a wake-up call, and it led to a complete redesign of the Apollo command module. They made it more fire-resistant, and they significantly improved its safety features. The tragedy, while heartbreaking, ultimately led to a much safer and more robust spacecraft design.
Yeah, it's remarkable how they turned such a devastating event into an opportunity to learn and improve. So after the Apollo 1 fire, how did they get the program back on track? Were there any missions that were particularly crucial in paving the way for that eventual moon landing?
Oh, there were several key missions that really served as stepping stones. Apollo 7, which launched in 1968, was the first manned mission after the Apollo 1 fire, and its primary objective was to test that redesigned command module and to prove that it was safe for crewed spaceflight.
So Apollo 7 was all about restoring confidence in the spacecraft
Right.
and demonstrating that NASA had really learned from the mistakes of the past.
Exactly, and it was a success. Apollo 7 proved that the redesigned command module was reliable and ready for that next challenge, going to the moon. And that's where Apollo 8 comes in.
Ah, yes, Apollo 8, the mission that took humans to the moon's orbit for the very first time. That must have been an awe-inspiring experience for those astronauts.
Oh, it was a pivotal moment in the history of space exploration. I mean, for the first time, humans witnessed the far side of the moon, a sight previously unseen by human eyes. And of course, they gave us that iconic Earthrise photo, that breathtaking image of our blue planet rising above the lunar horizon.
That image had a profound impact on the world, didn't it?
Absolutely. Seeing Earth from that perspective, this small, fragile sphere suspended in the vastness of space, really drove home the realization of our planet's vulnerability and sparked a growing awareness of the need to protect our environment.
It's amazing to think that a single photograph could have such a lasting impact on our understanding of ourselves and our place in the universe. But Apollo 8 didn't land on the moon, right? So what were the next steps in that direction?
Well, before attempting a landing, NASA needed to make sure they had all the pieces in place, and that's where Apollo 9 and 10 came in. They served as crucial dress rehearsals for the moon landing.
So what did they specifically test during these missions?
Well, Apollo 9 focused on testing the lunar module, that specialized spacecraft designed to detach from the command module and actually land on the lunar surface. They wanted to make sure that it could operate effectively in space and that the docking procedures between the lunar module and the command module were flawless.
So Apollo 9 was all about proving the lunar module was up to the task.
Precisely. Then Apollo 10 took things even a step further. It was a full dress rehearsal for the moon landing. They flew the lunar module all the way down to within 9 miles of the lunar surface, practicing the descent and ascent procedures.
Wow, that must have been nerve-wracking, being so close to the moon but not actually landing. Can you tell us a little bit more about the technical details of this lunar module? Like, what made landing on the moon possible?
The lunar module, or LM for short, was a real engineering marvel. It was designed specifically for the lunar environment, with a lightweight structure and a powerful descent engine to control its landing. It had 2 stages, a descent stage that carried the engine and the landing gear, and an ascent stage that housed the crew cabin and a smaller engine for liftoff from the moon. The LM also had a sophisticated guidance system. It used computers to actually control its descent trajectory and to ensure a precise landing.
So the LM was essentially a two-part spacecraft.
Yeah,
One part to get them down to the surface and another to bring them back up to lunar orbit.
exactly. And each stage had its own unique set of challenges. The descent engine had to be throttleable, allowing for precise control during the landing, and the ascent engine needed to be powerful enough to escape the moon's gravity. And then rendezvous with the command module that was waiting in orbit.
It's incredible how much complexity went into this single spacecraft.
Mm.
It really highlights the incredible engineering prowess at NASA at that time. So with Apollo 7, 8, 9, and 10 successfully paving the way, the stage was set for humanity's first attempt to land on the moon, Apollo 11.
That's right. Apollo 11 was the culmination of years of hard work, innovation, and an unwavering determination.
Let's talk about that mission in detail next time. We'll pick up right where we left off and relive that historic moment when humans first set foot on another world.
Apollo 11, launching on July 16, 1969, carried astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins on a mission that would change history forever, their destination, the moon.
And I think it's safe to say the entire world was watching with bated breath.
Absolutely. On July 20th, 1969, Neil Armstrong became the first human to set foot on the lunar surface, uttering those immortal words, "That's one small step for man, one giant leap for mankind."
It's hard to even imagine what must have been going through his mind at that moment.
It was a moment that truly transcended borders and ideologies, uniting humanity in a shared sense of wonder and accomplishment. Shortly after Armstrong, Buzz Aldrin joined him on the lunar surface, and together they spent over 2 hours exploring this alien world.
What did they actually do during their time on the moon? I mean, it must have been more than just planting the American flag, right?
Oh, of course. While planting the flag was certainly a symbolic gesture, their primary objectives were scientific. They collected over 47 pounds of lunar rock and soil, which would provide invaluable insights into the moon's composition and history. They also deployed several scientific instruments, including a seismometer to measure moonquakes and a laser reflector to precisely measure the Earth-Moon distance.
So Apollo 11 wasn't just about reaching the moon, it was about unlocking its secrets and expanding our scientific understanding. But the story of Apollo didn't end there, did it?
Not at all. There were 6 more Apollo missions that landed on the moon after Apollo 11, each mission building upon the previous one, venturing further, staying longer, and conducting increasingly sophisticated scientific experiments.
Can you tell us a little more about these later missions? Did any stand out as particularly significant?
Well, Apollo 12, landing just a few months after Apollo 11, demonstrated some remarkable precision. They landed within walking distance of Surveyor 3, a robotic probe that had landed on the moon back in 1967. They even retrieved parts of the probe to bring back to Earth for analysis.
That's incredible. It really shows how quickly they were refining their techniques. Did all the subsequent missions go as smoothly?
Not exactly. Apollo 13, launched in 1970, is a prime example of what we call a successful failure.
A successful failure. That sounds intriguing. What happened?
Well, during the journey to the moon, an oxygen tank exploded, crippling the spacecraft. The landing had to be aborted, and the mission became a desperate fight for survival.
It must have been terrifying for the crew and for everyone back on Earth.
It was one of the most dramatic moments in spaceflight history, but thanks to the quick thinking of the crew and the ingenuity of the engineers at Mission Control, they managed to turn a potential disaster into a remarkable story of sheer resilience and teamwork.
How did they manage to survive and return home safely after such a catastrophic event?
Well, they used the lunar module as a lifeboat, relying on its limited resources, and its engine to slingshot them around the moon and back toward Earth. It was a risky maneuver, but it worked. Apollo 13 showed the world that even in the face of, well, overwhelming odds, human ingenuity and a refusal to give up could prevail.
What an incredible story of human courage and resourcefulness. It's amazing to think that they managed to turn such a dire situation into a triumph. So after Apollo 13, what were some of the highlights of the remaining missions?
Well, the later Apollo missions, 14 through 17, marked a significant expansion of lunar exploration. They involved longer stays on the lunar surface, allowing astronauts to venture further and conduct more in-depth scientific research.
What enabled them to do more on these later missions?
Well, a real game changer was the introduction of the Lunar Roving Vehicle, or rover for short. This battery-powered lunar dune buggy, first used on Apollo 15, gave astronauts a much greater range of mobility. They could explore a wider area and collect more diverse samples.
It must have felt like a whole new era of lunar exploration, being able to drive around on the moon.
Oh, it was. It was a remarkable feat of engineering. The rover had to be lightweight, yet durable enough to handle the lunar terrain. It had to be able to navigate over craters and rocks, and it had to be reliable, as there were no mechanics on the moon to fix it if it broke down.
It sounds like the rover really opened up a whole new world of possibilities for scientific exploration on the moon. What were some of the key scientific discoveries from these later missions?
Well, the later missions focused on gathering more detailed geological data, studying lunar craters and mountains, and deploying more sophisticated instruments to probe the moon's interior and its magnetic field.
Were there any specific findings that stand out?
One of the most significant findings was the discovery of orange soil on Apollo 17. This turned out to be volcanic glass beads, evidence of ancient volcanic activity on the moon. This discovery provided valuable insights into the moon's early history, revealing a period of intense volcanism billions of years ago.
It's amazing how much we can learn about the moon's past by studying its geology. Apollo 17 was also notable for carrying Harrison Schmitt, the only geologist to walk on the moon, wasn't it?
Yes, that's right. Harrison Schmidt's expertise in geology was invaluable. He was able to provide real-time analysis of the lunar landscape, guiding the mission's exploration and sample collection. His observations and the samples he collected have helped us piece together a more detailed picture of the moon's formation and evolution.
It's incredible to think that we had a trained geologist right there on the moon, able to interpret the landscape firsthand. It highlights how the Apollo program evolved from simply proving we could reach the moon to a more focused scientific endeavor.
You're absolutely right. The later missions demonstrated a growing emphasis on scientific research, and the knowledge gained from those missions continues to shape our understanding of the moon today. But it's important to remember that the Apollo program wasn't without its critics.
What were some of the main criticisms leveled against the Apollo program?
Well, some people argued that the enormous cost of the program, which is estimated to be over $150 billion in today's money, could have been better spent, addressing pressing issues here on Earth, like poverty or hunger.
Yeah, I can definitely see that point of view. It is a lot of money to spend on exploring another world when there's so many problems to solve right here at home.
Right, and others argued that Apollo was primarily driven by Cold War politics, rather than pure scientific curiosity. I mean, the desire to beat the Soviets to the moon certainly played a role, but it also fueled an unprecedented wave of technological innovation that had far-reaching benefits.
Can you give us some examples of those technological spin-offs?
Yeah.
How did the Apollo program actually impact technology here on Earth?
Well, think about the miniaturization of computers, for example,
Yeah.
which was essential for guiding the spacecraft and managing its complex systems, right? The advancements in integrated circuits, driven by the demands of Apollo, paved the way for the personal computers and smartphones we rely on today.
Oh, wow. I never really thought about it that way.
And Apollo also spurred innovation in materials science. The need to develop lightweight, durable materials for the heat shields and spacesuits led to advancements in insulation, fire-resistant fabrics, and even medical implants.
It's amazing how Apollo's legacy extends so far beyond the moon itself, touching so many aspects of our lives today. It's clear that the program had a profound impact on science and technology. But what about its cultural impact?
Oh, well, Apollo had a profound impact on our culture as well, inspiring generations to dream big and pursue careers in STEM fields. The moon landings captivated the world, reinforcing the idea that humanity, working together, could achieve seemingly impossible goals.
It was a moment that really transcended national boundaries, wouldn't you say?
Absolutely. It was a shared human achievement that filled people with a sense of pride and wonder. And those iconic images from Apollo, the astronauts walking on the moon, the Earthrise photo, have become enduring symbols of human ingenuity and our boundless capacity for exploration.
It's hard to believe that it's been over 50 years since the last Apollo mission. Has there been any interest in returning to the moon since then?
Oh, absolutely. There's a renewed interest in lunar exploration these days. NASA's current program, Artemis, aims to return humans to the moon by the mid-2020s. This time with a focus on sustainable exploration and establishing a long-term presence on the lunar surface.
So it's not just about planting a flag this time. What are the main goals of the Artemis program?
Well, Artemis aims to establish a base camp on the moon, allowing astronauts to stay for longer periods and conduct more extensive research. It's also seen as a testing ground for technologies and strategies that will enable us to explore further into our solar system, like a crewed mission to Mars, for instance.
Wow, it sounds like the moon is being seen as a stepping stone to even more ambitious goals. What are some of the challenges they'll face in establishing a long-term presence on the moon?
One of the biggest challenges is radiation. The moon doesn't have a protective atmosphere like Earth does, so astronauts will need to be shielded from harmful cosmic rays and solar flares. Another challenge is the extreme temperatures. The lunar surface can reach scorching temperatures during the day, and then plunge to frigid lows at night. They'll also need to find ways to extract and utilize resources on the moon, like water ice, for example, to reduce our reliance on supplies from Earth.
It sounds like there are quite a few technological and logistical hurdles to overcome. But it's exciting to think about the possibilities that will open up. Once we have a sustainable presence on the moon, what kind of scientific research could be conducted from a lunar base?
Well, a lunar base would be an ideal platform for astronomy. Without an atmosphere to distort observations, telescopes on the moon could capture incredibly clear images of distant stars and galaxies. It would also be a great place to study the moon itself in more detail, from its geology to its potential resources. And it could serve as a launch pad for missions further into our solar system. You see, the moon's lower gravity makes it easier and more efficient to launch spacecraft from there.
So the moon is not just a destination in itself, but a gateway to further exploration. It's incredible to think how far we've come since those first tentative steps on the lunar surface.
The Apollo program was a pivotal moment in human history. It not only demonstrated our technological prowess, but it also ignited our imaginations and inspired us to dream of reaching for the stars.
As we stand on the cusp of this new era of lunar exploration, it's important to remember the lessons learned from Apollo and to approach these new endeavors with a sense of responsibility and a deep respect for the lunar environment.
Well said. The moon is a pristine world, and we need to ensure that our presence there is sustainable, and that we preserve its scientific and cultural value for future generations.
The Apollo missions were truly a giant leap for humankind, not just in terms of technological achievement, but also in expanding our perspective and inspiring generations to come. As we continue to explore our cosmic backyard and beyond, let's carry that spirit of discovery and responsibility with us. And that brings us to the end of our deep dive into the Apollo program. What new discoveries and possibilities await us as we continue to explore our cosmic backyard and beyond? Don't forget to follow us on social media for more space and astronomy content. And be sure to subscribe to Cosmos in a pod form on your favorite podcast platform so you don't miss an episode. Until next time, keep looking up.